Ice. Ice, ice, ice. Ice is strange. Almost every solid substance on Earth sinks when placed in its liquid form. Solid aluminum sinks in molten aluminum. Solid wax sinks in melted wax. Solid rock sinks in molten rock. But ice floats. And that one unusual property helps make Earth livable. Most materials become denser when they freeze. The molecules slow down, pack together tightly. Water does the opposite. When water freezes, its molecules arrange themselves into hexagonal crystal structure. This structure actually takes up more space than liquid water. That's why it's about 9% less dense than water, and why it floats. This might seem like a small detail, but it changes everything. Imagine if this wasn't true. Imagine if ice was denser than water. Imagine a winter without floating ice. If ice sank, lakes, oceans would freeze from the bottom up. Each winter, more ice would accumulate at the bottom, and eventually, entire bodies of water could freeze solid. Instead, floating ice forms an insulating layer on top of the water. Underneath that layer, liquid water remains above freezing. Fish survive, ecosystems continue. Without floating ice, most freshwater ecosystems would collapse, and life as we know it would have never evolved. One of the most important formations of ice are glaciers. Glaciers don't just sit still, they move. And over long enough timescales, they've reshapen our Earth. Now, a glacier might just look like a frozen landscape, but it's actually a slow-moving river of ice. Under its own enormous weight, ice crystals deform and slide past each other, allowing the glacier to flow downhill. Sometimes just a few centimeters per day, sometimes several meters. This slow motion is incredibly powerful. As glaciers move, they grind rock into powder, drag massive boulders across valleys, and carve the land beneath them like sandpaper. Some of the most dramatic landscapes on Earth exist because of this process. And all of this possible because ice floats. Ice is also one of Earth's most important climate regulators. Fresh snow reflects about 90% of Earth's incoming sunlight. This is called the albedo effect. More ice means more sunlight reflected back into space. Less ice means more heat absorbed by oceans and land. This creates a feedback loop: less ice, more warming, less ice. Ice acts as Earth's thermostat. It's hard to believe that because of this substance's unusual physics, it has shaped this planet so profoundly. It's not just important to us on Earth, but it's also vital to our exploration and possible habitation of Mars. Ooh. Dun, dun, dun. When we imagine Mars, we usually picture a dry, dusty, lifeless planet. But Mars isn't just a desert. It's a frozen world. And that ice, and that ice, and that ice might be the single most important resource for exploring and possibly living on Mars. Orbiters using radar have discovered ice beneath the Martian surface, sometimes just a few feet deep. In some regions, the ground's more like permafrost, which is like a ice, dirt, dust mix. For the Mars-curious explorers, this changes everything. In space, water's not just for drinking or watering plants. Its main purpose we need it for is fuel. Rocket fuel. Water is made of two elements, hydrogen and oxygen. And these two elements, when separated, form the most powerful rocket fuel ever used. Liquid hydrogen and liquid oxygen power many modern launch systems. For a rocket scientist, the chemistry is simple. Using electricity, water can be split into hydrogen and oxygen in a process called electrolysis. H2O becomes hydrogen gas and oxygen gas. The hydrogen becomes the fuel, the oxygen becomes the oxidizer. Together, they create a high-efficiency rocket propellant. Now, why does this matter so much? Launching fuel from Earth, sending it all the way to Mars is incredibly expensive. Fuel is one of the heaviest things spacecrafts carry. So instead of bringing fuel from Earth, future missions plan to make fuel on Mars using local resources. Having ice on Mars makes colonizing way more possible. A future Mars mission could mine ice from the ground, melt it into water, purify it, split it using electrolysis, liquefy the hydrogen and oxygen, and store it as a rocket propellant. Mars would then become its own fuel station. Ice on Mars can solve the hardest problem for colonizing it. Getting to Mars is extremely difficult, but getting back is harder. A return rocket normally requires huge amounts of fuel. NASA's future mission plans often rely on producing fuel ahead of time using robotic systems. So the astronauts would fly to Mars, do their mission, refuel, and head home. If astronauts arrive to Mars and the fuel's already waiting for them, the mission becomes a lot more possible. While rocket fuel is incredibly important, it's just one purpose that we can use the ice on Mars for. The ice can also provide drinking water, breathable oxygen, radiation shielding, temperature stabilization, and agricultural support. Now, just like on Earth, ice can hold the secrets to the Martian past. On Earth, microbes have survived frozen glaciers for thousands of years. If life existed there, ice deposits could still contain chemical or biological evidence. On Earth, ice makes life possible, and so too on Mars.